is inference. Now, this is a big word that we are going to use a lot. This is what this class is about. This is what this class is about. This is what this class is about. Okay? If we understand inference, you're going to understand this class. Okay? So, this is what we're gearing towards. It's the process of drawing conclusions about a population based on the sample size. Sorry, sample data. Process of drawing conclusions about a population based on a sample data. We're going to spend the entirety of semester 2 talking about inference. Semester 1 is gearing towards that. All of it's geared towards inference. Okay? So what we're doing right now is we're trying to figure out how to sample well, how to get a good sample so that my data is accurate and precise. How do I do that? Okay, that's our goal in this class. Later on, we're going to make some conclusions from that sample data. In an ideal world, we would just know the population proportion or the population mean. That's ideal. What's the problem with that? It's hard to obtain, right? Even if I was doing the height of everybody in GAC's high school, that would be really hard to get, right? That's a lot of people that have to go around and get their height, measure them, do all that stuff. That's 650 feet. It takes a long time. It's a lot easier to get 40 and then make a conclusion about the average height. It just is, okay? So generally, we're not going to have that population data. We're just going to have sample data, okay? So what is sampling variability? Sampling variability. Sampling variability is something that we can't eliminate. We can't get rid of it, okay? But we can control it a little bit. And there's ways to control it we'll talk about. So sampling variability is how far we expect the sample data or sample proportion to be from the true data or true proportion. Okay? So in that river data, how far it was away from the actual value, how spread out it was, that is sampling variability. Okay? We sampled, each of you got a sample of size 10 for each different river sample, and we combine those to get our sampling distribution. The variability is that thing that we can't really eliminate. It's not possible to eliminate. Okay? Now, margin of error is a part of that sampling variability. Has anybody seen a poll on like the news or in a newspaper or on a magazine that at the very bottom there's like that plus or minus 3% or something like that? That's margin of error. Okay? It's saying that this is the result that we think it is, but there could be some error in either direction by 3%, right? You see that a lot with, what's the presidential thing called? The approval rating, okay? President Obama's approval rating was 55% with a margin of error of 3%. So that means that it could be anywhere from 52 to 50, no, sorry, I can't, yeah, 52 to 58. Sorry, math isn't my strong suit, okay? What is a margin of error? It's nothing that we can control, right? Not a mistake, doesn't correct for bias, it's just variability. It's not something that we can control. Now, can I decrease sampling variability? Yes, there's two ways to do that. The first way is to sample well, okay? I'm going to choose the best possible method to sample. Normally that's stratified, sampling with the stratified sample. It's just generally going to decrease your variability, increase precision. Another way is to increase your sample size. Increase your sample size. Okay? Increasing your sample size is going to increase your precision, but it's not going to increase your accuracy. Okay? It's going to increase your precision, not your accuracy. That's a key distinction. But the bigger the sample I have, the closer I'm going to get to the population. Right? So the more people I have in my sample, the more precise my estimate's going to be. Now, what's the drawback of a bigger sample size? Harder to take a sample size, takes more time, maybe costs money, resources, right? So those are real effects of increasing sample size. questions on that? All right, well, the last page. Now, sampling frame, I am never, ever going to ask you a question, and you will never get asked the question, what is sampling frame? And you have to regurgitate that information. But I think it's important to know what a sampling frame is, just because you might see it sometimes. But sampling frame is just the source material or the device from which a sample is drawn. So, if I was trying to get the GAC senior high school class to give me their average height, how would I get the list of students? Well, I would probably print it off from the director. That would be my sampling frame. Okay, that's all it is. Let me kind of track back and kind of give the difference between stratified and cluster, just to kind of bury that point home, and then we'll talk about bias. Okay, so if I was trying to find, I wanted to find all of GAC's opinion on the dress, students' opinion on the dress code, K2 through 12, right? And I did a cluster sample, and I wanted 3 grades. It's possible that I got K2, K3, K4, right? In my sample, or it's also possible I get 10, 11, 12. Probably a big difference in opinion on dress code. My daughter's in K2. She loves her uniform. Loves it. I don't know how long that's going to last, right? But 10, 11, 12 probably don't have the same opinion, right? If I was trying to represent the population better, I would do a stratified random sample. Get some from K2, from K3, K4, K5, all the way up to 12, right? And that would be a better representation of my population. Does that make sense? How that's a little bit different, those two things. Strata, I would SRS every single grade. Cluster, the 3 that I pick, those are the grades that I'm asking everybody in that grade. Might be easier for me to get, but it's not going to be right.
Randomly selecting the number of groups.
Yeah, I'm going to do an SRS with each group in the stratified. And that's basically going to be a better estimate, right? So we have 3 different types of problems that might occur. Some that we can control, some that we cannot. Okay, under coverage is something that we can control. Okay, under coverage, I think I have the definition. Under coverage is when some members of a population cannot be chosen. When some members of a population cannot be chosen. So I want to figure out the average age of the households in the state of Georgia. Let's just do Gwinnett County. Average age of the household in Gwinnett County. So everybody in the house, add up their ages, divide by however many people are in the house. We got it? So I get a list of landlines. Get a list of landlines. Everybody in Gwinnett County gives me I get their landlines. And I do a simple random sample. And I get a sample of size 100, and I call everybody on that list, and I get the average household for those people that are in my sample. How is under coverage a part of it? Houses that don't have a landline, could they be selected for the sample?
No.
Are they a part of the population?
Yes.
Yeah. I don't have a landline. Okay. My average would be pretty low, right? That would probably overestimate the average age of household. Right? The older the adult, maybe the more likelihood they're going to have a landline. I don't know. I might be the only person in here that doesn't have a landline. But I don't think I do. So it happens, right? So that's what under coverage means. Does that make sense? So it's not going to represent the population that we're looking at because some people aren't going to be a part of that. Okay? All right. Non-response. Non-response is something, so we can control this. Our sampling frame has to be good, right? We have to make sure that everybody is on the list that's in the population. Okay, not just. Non-response is something that's hard to control. Very hard to control. You're going to be doing a project both semesters, and this will be your number 1 issue. Number 2 issue will be procrastination. Number 1 will be non-response. Well, it could be flipped. Hopefully it's not flipped. But number 1 will be non-response. What is non-response? Okay, non-response is when an individual that's chosen for the sample simply can't be contacted or just flat out refuses to participate or doesn't respond. Right? I select the sample, I do everything right, and this stupid ninth grader doesn't check their email. And I email them 15 times and they still don't respond. It's normally ninth graders, but all grades participate in non-response. Why is this an issue? Well, the people that don't respond could have an opinion based on that might change my sample data. Okay, that's why that's an issue. So non-response, big issue. Okay, you just got to track people down. Sometimes you got to go face to face. You just got to do it. Okay, this is one of the hardest things that we have to deal with. Now, how is that different than voluntary response?
They were still chosen.
Okay, so in this case, they're still chosen. Voluntary response, nobody was chosen. Everybody can respond if they want to, right? So there's no non-response in that voluntary response thing because there is no sample. It's just the entire population. Does that make sense? The last one is kind of one of the coolest ones that I think we have, and we can 100% control this. This is called response bias. Our project in this semester, we're going to try and create response bias. Now, in a good sample, that's not a good thing. We're going to see, kind of experiment with that and see how we can do that. So what is response bias? There's a lot of different types of response bias. There's wording bias. There's interviewer bias. There's human nature bias. Order of the question response bias. So on and so on and so on. There's so many different ways of response bias. Let's go over 2 of them. Wording and interviewer bias. So wording bias, I have 2 different questions that I ask. The first one is, do you support the war in Iraq? Yes or no? Second question, we've lost X amount of U.S. soldiers in the war in Iraq. Do you support the war in Iraq? Yes or no? What's the difference between those 2 questions?
One negative, a little bit more bias. Context.
Same context of the question, right? Same essential question. But the second question, I'm giving you some fact about the war in Iraq that's maybe going to lead to a negative response, right? It's going to overestimate the number of no's, probably, right? That's wording. Interviewer bias, and this is one of the coolest ones. Interviewer bias. Last year, 2 years ago, I had a group do this. They asked the same question. Are you more attracted to females who wear makeup or not, or don't wear makeup? Same girl went up to the people in the sample that were supposed to get question 1 with a lot of makeup on. Asked them, do you prefer females who wear makeup or not? Next sample, no makeup on at all, asked the same question. First question, probably going to get more makeup. The second question, probably going to get a more accurate response. Okay? There's response bias there in the way the interviewer is presenting themselves, right? So that's what response bias